All right, before we get today's lesson started, I have a couple of housekeeping items for everybody. First one belongs to both Mason and Ryan. I hope the two of you have headphones today. Otherwise, class is going to be really annoying hearing my voice come through about 23 computers. John, this one's for you. I do not have the summer exams posted into Gradebook yet online. However, I will let you know that they are in fact graded. So that's a start. We're getting going with everything. Something I want to just let everybody know, if at any point in time during the video, feel free to stop, pause, whatever it is you need to do to get some things jotted down. So the first thing I want you all to do is I want you to take out the worksheet that we had yesterday. That talked about our squares and square roots, because this worksheet right here is going to be extremely beneficial for you guys today. Secondly, I also want you to make sure that you have the notes for today. Now, today's lesson is focusing on estimating square roots, okay? And before we can estimate what certain square roots are, we got to make sure we have two key components of notes down pat. The first one is going to be perfect squares, and the second one is going to be non-perfect squares. So you're going to see me go between Internet tab, and I've made a Smart Notebook file for everybody, so we can kind of go along with it. Now, like I said, I really want you to make sure you guys have your squares and square roots worksheet out, because this is something that is going to be very, very beneficial to you. And I remember yesterday we filled these in. I didn't do all of them, but got a good chunk of them down there. So first thing we're going to do, we're going to have ourselves a definition for what exactly is a perfect square. And I know one thing you all do is believe everything you read on the internet, so I figured why not go to the internet so I can show you a definition of a perfect square. So a definition of a perfect square is going to be the product of two equal integers. And that's something, feel free to go ahead and jot down in your notes. It's going to be the product of two equal integers. And basically what we are doing is making sure that we take two particular numbers, multiply them together to get that perfect square. So for example, here we have 9. 9 is a perfect square because we can think of it as 3 times 3, but also do keep in mind I did say integers, which means from our number root system, we can think of integers as negatives as well. If we think about it, -3 times -3 is indeed 9. Also, perfect squares are always going to be rational numbers, okay? Um, and a perfect square example, like I said before, 9 is a great example of a perfect square, along with 16 is a perfect square, 25 is a perfect square. Basically, if we go back to this list, anything right here in black is considered a perfect square. A number times itself to get that perfect square. Now, a perfect square was a rational number, and I'm willing to bet you all can guess as to what a non-perfect square is. And yes, several of you most likely did say an irrational number. Okay? Now, a non-perfect square basically means what we're trying to do is not having two numbers that can get to that essential non-perfect square number. So for example, 8 is a non-perfect square. We do not have any equal integer that can multiply and get 8. So you're going to end up with a non-repeating or a non-terminating, non-repeating number for it to be irrational. 5 is an example of a non-perfect square. 11 is an example of a non-perfect square. Okay. So as I said, our focus today for today's lesson is being able to estimate square roots, being able to take a guess as to where a square root will be. And like I said, feel free to pause at any moment if you guys need to. But the first thing we're going to do is we're going to go ahead and estimate about what the square root of 50 is, okay? Now, in order to do that, what we are going to do is we're going to use a number line, and we're going to fill in the number line and then kind of plot where we think the square root of 50 will be. We're also going to be using our perfect square sheet. Okay, so what I want you to do right now is take a moment, and you have the square root of 50. Take a moment, and which of these perfect squares do you think we can put the square root of 50 in between? Go ahead and take a moment, pause, and then see if you are right. I'm hoping that you are noticing the square root of 50 is going to fall in between the 49 and the 64. Okay, so we have 49 on this side of our number line. I'm just going to start writing here to be easy. And we also have 64. Okay, now you can see 49 is 7 squared, and 64 is 8 squared. Okay, now we know that the square root of 50 is somewhere in between the 7 squared and the 8 squared. Now what we're going to do is we're going to take a better guess as to where the square root of 50 will be. Now if we take the square root of 50, we notice it's going to be probably around here somewhere. And notice 50, which is the spot that I graphed, is only 1 away from 49, and it's 14 away from 64. So it's way farther away from the 8 squared than it is from the 7 squared. Okay? Now, since 50 is closer to the 49, the square root of 50 is going to be way closer to the 7 squared than it is going to be the 8 squared. Okay, or it's going to be way closer, I should say actually, to 7 than it is to 8. Okay, now here's what I need you to do right now. I want you to take a moment and answer me this question inside your head. Okay, we have on the top here, we've got 7 squared and 8 squared, and we know this is about the halfway point in between. What I want you to do is pause your video after you answer this question and take a brief guess as to what you think a good decimal estimate would be in order for the square root of 50. Go ahead and pause for about 2 seconds and write down what you think the estimation would be. Now, hopefully after you unpause it, you notice that it's going to be a little bit over 7. So I would say a good guess for the square root of 50 would probably be about 7.1, or I would even accept 7.2. Okay, now you'll notice in the middle here, you have 7 and 8, and middle is 7.5, and you notice it's way over to the left. So it's probably closer to 7.1, 7.2. Now, I know some of you are probably struggling a little bit with, well, which one is it, Mr. Sadler? Which one's going to get me the correct answer on the test? Please do keep in mind, kiddos, that I'm very lenient. As long as you give me a good explanation as to why you chose it, I'll be somewhat lenient in your answer. Okay? Now, example 2, what I want you to do is you can either follow along with me on this one, or you can pause it if you think you might have a general understanding of what we're working on here. Okay? Now, for example number 2, we're going to ask you to estimate the square root of 22. Now, if we go back to the other page, once again, and we look at our perfect square list here, we're going to look for 2 numbers that somewhere the square root of 22 can be. So we're looking right about here. Square root of 22 is going to be somewhere between 16 and 25. So we're going to use the 4 squared and the 5 squared is what we're going to do. Okay. So I'm going to go ahead and put 16 down, and then I'm going to go ahead and put the 25 down. Okay, now remember 16 is 4 squared and 25 is 5 squared. And what we're going to do is go ahead and take a guess as to what we think our estimate would be. So we have 4 squared and 5 squared. Okay, and I'm going to go ahead and plot 22 in purple right about here. Now go ahead and take a guess. Is it going to be closer to about the 4 squared, or the 5 squared?